As we start the practice now and review of topic 3.5 on variations, keep in mind there are basically two forms: direct variation, which is y equals kx, and inverse variation, where y equals k over x. Now the x may contain a power other than 1, but our first shot at these is to read and then pick out which formula and then convert it to the letters reflected in the example. So let's do number 1. Suppose y varies directly as the cube of x. So it's going to be then, for this one, y equals k, and then the cube of x. So we've translated what they've said into our basic form. Now, step 2 is to substitute. Y is going to be 17. We don't know what our k is, and x is 4. So we'll put that in parentheses because we're going to raise that to the third power. Now, what is y when x is 3? Okay, so what we need to solve for here is the constant of variation by dividing both sides by, and 4 to the third is 64. So rewriting it then, y equals our new value of k, and then we're going to put here x is 3 to the third power. So do some calculation and see what you get. They want your answer rounded to 2 decimal places. So 3 to the third is 27. 17 times 27 is 459. Divided by 64 is this. To round to 2 decimals, we go to our third, which is a 1, so we just drop it. And this will be the answer to number 1. And again, these are right from the practice and are very similar to the certify. So looking at this, read number 2 and see which formula you'd pick out. Did you get something like this? Distance, again, it's direct variation. Distance equals your constant of variation to the square of the time. So step 2 is to find what k is by substituting our 52 feet for the distance. We don't know the k, but the time in 7 seconds is this. So keep in mind we're going to square this. We can probably do this here, 52. 7 squared is 49, so we're going to divide both sides by 49 here. So k then equals 52/49. So our equation of variation then will be d equals 52/49. And then our new time is going to be 8 seconds that we're going to square. All right, take a moment, see what you can figure out there. So 8 squared is 64 times 52 is 3,328 divided by 49 is 67.9. They want it to the nearest integer, so that will be like a whole number, and that would be 68. All right, let's go on to number 3. Now in number 3, we're wondering Which of the formulas do we use? Is it direct, inverse, or a combination? Well, it says here electrical resistance, we can use an R for resistance, varies directly as the square of the voltage and inversely as the electric power. Okay, see what kind of formula you can come up with. Did you get something like this? Now, P is the power, and voltage is 14, power is 2 watts, and the electrical resistance is this much. All right, substitute and see what you come up with. Something like this up to this step. Now keep in mind our resistance is 98. Our voltage is 14 that we have to square. And our power was 2 watts. Now, in solving this, think of it as a fraction, this over 1, and we can cross multiply in a sense. 2 times 98 gives us this, and we multiply the 1 by this, and we're left with the K then there. So this is what K is. And let's find out what K is by doing this, and that'll be our answer. So this works out to be 196 over 196. So our K value is 1. And again, you'd have to put that into the answer box and use the appropriate things to submit. Following our protocol, you want to read this carefully and then come up with a formula using appropriate letters, keeping in mind that this is jointly area and velocity, and let's see what you get. Okay, something like this. The force is equal to some constant of variation times the area times the velocity squared. All right, next step, put this data to solve for K. So the lifting force is 2,400. We don't know what K is. Our area is 220 square feet, and the velocity is also 220 miles per hour. So we have two numbers that look alike. Be careful, the velocity is squared. So if I divide both sides by this, which is what I show here, we get under K, and on this side it looks like this. So the first thing we have to do is find a value for K. You could put that in your memory, and then once you have that value for K in your memory, you're going to multiply by 220. Square feet stay the same, but now the velocity is slower, 200, that you're going to square, and then you're going to round your answer to the nearest integer, so that'll be a whole number. All right, let's see what you get. This is your practice. So what I did on my calculator is I put this into the calculator, got a value, which is then this, that I multiplied by this and this squared. When I did all that, I got this with 2 decimal places, and it's to the nearest integer, so If this were 5 or more, I'd make this 3 a 4, but the way it is, I'm just going to drop it. And this is my answer. And notice it's relatively near the 2400. With less speed, you have less force of lift. And that's why planes have to fly at a certain speed on the runway to develop enough lift so that they can get off the ground. And of course, maintain that speed if they want to stay up in the air here. A little bit of physics. Okay, let's go on to our next one. Looking at number 5, I should have hidden this, but let's see if you agree. So a safe load is L equals K, your constant of variation, varies jointly as the width, which is W, the square of the depth, that is D, and inversely, and I see I have that incorrect here, didn't read that too well, inversely as the length. Okay, and here we're using a capital L for load, lowercase l for length. Now, we'll let you do the substitution and see how you would find K. So there is the current load. We don't know our K. Our initial width here is 6. Our length, or our D, I should say, 6 inches that we're going to square. And then our length is 3 feet. Okay, hopefully we set that up correctly. Now to solve for what K is, I'm going to cross multiply and get 3 times this, which is this. And then I'm going to divide by, can you see there's 1, 2, 3, 6 to the third here? So this would be my value for K that I'm going to put in my calculator, get a value here, multiply it by 2, and then I could just do a 9 here. And once I get that value, I'm going to divide by 13, and we'll see what I get. Now, I didn't round off here, kept that value, multiplied by 2 times 9, divided by 13, got this, and then rounded to the nearest whole integer, and I got this. Okay. And that answer seems reasonable. All right, let's follow our same protocol. Pause, read it, see what kind of formula you could come up with. This is a combination. Did you get something like this? Now, in the next step, you're going to substitute these values into the formula and solve for a value of K. Let's see what happens. Okay, something like this. Now our A value is 126. We don't know our K, but our B value is 4 that we're going to square, and our C value is 5 that we're going to square. So what is K? Well, again, I can kind of cross multiply. This is going to be 25 times 126, and then 4 squared is 16. So this is my value for K. Now I can get a value for this, which is what this is, multiply it by 81, which is 9 squared, and then divide it by 8 squared, which is 64, and let's see what you'd end up with. And they want us to round to 2 decimal places on this one. Okay, what I did is I did this multiplication, 126 times 25 divided by 16. That gave me this value here that I then multiplied by 81. Then I divided that total by 64, and I got this. Now to round to 2 decimal places, I go to the third, which is a 9. So I'm going to drop the 9 and make this 6 a 7. So my final answer is 249.17. Now, keep in mind, don't round off because you're using your calculator until the very end. Otherwise, those little differences will start to make your answer off just a little. And again, as you put answers into the practice, that will give you your confidence that you're doing it correctly, getting hopefully the right answer. There is number 7. Give it your shot. You know the protocol. Taking it in steps, we know it's inverse, so we'll use this, and it's x to the 4th power. So y is 3, x is 7 to the 4th. We're going to get a value for k. K now equals 3 times 7 to the 4th power, which will be this. And then we're going to divide this by 3 to the 4th power, and then round to 2 decimal places. Let's see what you get. Again, you want to be able to put this into your calculator and get values that give correct answers. And when I did that, I got this, rounding to 2 decimal places, 88.93. 5 or more, we round up. 4, we just drop. Okay, just a few more. Now, for number 8, they're giving us an easy one, I think. Find the mathematical model for following statements. Z varies jointly as the 4th power of x and the 5th power of y. Write that out. Give you a moment. So hopefully something easy, and this is 5th power here. Okay, now for number 9, again, I think something easy. Let's leave that up here. A bookstore manager observes the number of magazines sold seems to vary inversely as the price per magazine. If the store sells this many magazines per week, when the price is this, how many does he expect to sell if he lowers the price to this? So again, follow the protocol, set it up, and let's see what you get. So something like this, n for the number of magazines. Since it's inverse proportion, it would be k over the price. So this many magazines, constant of variation, the price was $5. So again, just cross multiplying, I get k equals 5 times this, which is our k value, the new price of the magazine, how many would he expect to sell, and we're rounding to the nearest whole number, digit integer. So we're going to just drop that and it would be 583. Okay, so these weren't quite as complex as what we saw in the learn, but using those formulas and hopefully something a tad easier as compared to things that we were doing. All right, let's wrap this up.